Nizza.
Hello from Nice.
Mein Name ist Nicole Klinger. Ich komme vom Fraunhofer IWKS.
My name is Jennifer and I'm also from Fraunhofer IWKS.
Wir werden heute ein paar Wissenschaftler interviewen und uns umhören, in welchen Bereichen sie so forschen.
We will have some great, fascinating interviews with our researchers here today, and we'll learn more about their work and what they're doing with materials research. Hello and welcome to EMRS TV. Good morning to Mrs. Professor Brandi COSSAIRT. She's from the University of Washington. So thanks for joining us today.
Well, you're very welcome. It's a real pleasure to be here.
So the 2019 EMRS Spring Meeting brings together a wide variety of scientists. And what are your personal highlights so far from the conference, or what are you especially looking forward to?
Yeah, so two symposia in particular have really caught my attention. One is Symposium A, which is on solar fuels. I just heard a really great talk by Professor Song Jin from UIUC in Illinois. And the other is Symposium W, which is on electronic applications of nanomaterials. And that's the symposium I spoke in. So I'm biased, but I thought that was great. And I'm also looking forward to seeing Professor Amano speak at the plenary later this morning.
Yeah, he's speaking today, right?
Yes.
And why did you decide to come to the EMRS, or are you a regular visitor?
Definitely not a regular. So this is actually my first EMRS and my first international travel as a faculty member. So I saw it as a real opportunity to connect with my European colleagues. Probably the best science in my specific subfield is being done in Europe. So it's really good to put faces to all the names on the papers I've been reading.
Yes.
Yeah.
So it's also about connecting with the other scientists.
Networking and just meeting people and making real connections.
So, given the wide variety of topics, so we have materials for energy, we have bio, nano, and soft materials. So it's a very interdisciplinary approach. So how important is that to you?
Well, I think all of the important science today is being done at the interface of different subdisciplines. So there's really no pure science anymore, and so I think it is really important. And the conference seems to highlight that in a really good way. So yeah, that's great.
So the EMRS meeting is also about sharing and discussing the latest developments in research. And could you sum up what your field of research is about, and what are the latest developments in your specific field of research?
Sure. What we do in my group is try to understand the mechanisms by which nanomaterials nucleate and grow in solution, so how the atomic pieces come together. And then once we have those materials, how to manipulate their function by changing their structure or their surface chemistry. I would say the latest developments are just the sort of inclusion of chemists from different subdisciplines, different types of chemistry into this field. So I think traditionally it had been dominated by engineers, and there was a lack of understanding of what the bond making and bond breaking reactions really were going on to either make or manipulate these materials. And so that's something that's really starting to come to fruition in the last several years.
Okay. And could you explain what you do to someone who's not probably a scientist, or in a more simple way for all of you who are not
Probably if I go to the application side, that'll be easier. So one of the big applications of the materials we work on is in wide color gamut or broad color range displays and TVs. So we make color conversion materials, nanomaterials, for taking high energy blue light and converting it to red and green with very high color purity. And so the goal in the display industry is to make all the colors the human eye can see. And so for that you need very bright, very color pure emitters. And so that's really what my lab is after. Making emitters that can fulfill these needs and be cost competitive and not involve toxic heavy elements.
And do you already have something like successful applications?
So we work on indium phosphide quantum dots in particular, and so these are the leading drop-in replacements for cadmium-based materials. chemistry that's inspired by what we do and the work of others has proven successful in products by Samsung and others. So we're really excited. We've actually collaborated a bit with industry on some of our work, and it's been really rewarding.
Wonderful. So you mentioned that you want to replace cadmium, if I understood correctly. So we at Fraunhofer EWKS are also looking into replacing like scarce resources. Is this something because it's scarce, or is there another reason to replace it?
Right. So in this field, because we're working with very highly distributed technologies like TVs or light bulbs, which are going to end up in the landfill ultimately, it's really a toxicity concern. And I guess in the European Union, cadmium in consumer electronics is banned at certain levels. So it was a big priority to replace these cadmium-based materials with something that didn't contain cadmium. And so indium phosphide was recognized as the leading alternative. But as you point out with the scarcity issue, indium is actually a fairly scarce resource. But it turns out you don't actually need to use very much of these materials in a TV. It's milligrams at most.
So would you say that your research is also helping to protect the environment in some way?
So the one sort of environmental aspect to what we do is energy conservation. So these types of display technologies end up being a lot more energy efficient than your average because you're not wasting a lot of photons in the color filtering process. So you get huge energy savings. And the other main application of these color conversion materials is in solid state lighting, so LED lighting. And there's a huge environmental energy savings impact for sort of dialing in exactly the right color temperature to have people adopt them in commercial, residential, and other types of applications.
Great work. So talking about the resource or indium, do you think, because we are also trying to do like design for recycling, and we're also working on looking into how we can, well, put materials together and then also dismantle them again after their end of life. Do you think working with markers, for example, would be possible so you can track the indium and then regain it?
Would be, I think ultimately, because we're in highly distributed applications, because these things are going to end up potentially in the environment, that's going to be really important in the future. Right now, if you think about technologies that use toxic or scarce resources, there are recycling programs in place. So like cadmium telluride solar cells, for example. There's really good mechanisms by which you can recycle those materials. For these materials in displays, if I go out and buy one of these displays at the store, I'm not given a bunch of information about recycling. And so I think being able to trace the material from product to end of life is probably going to be very important.
Well, thank you for being with us.
Yeah,
and
my pleasure.
Have a nice rest of the conference.
Well,
Thank you very much.
Thank you.